Welcome back. In this video, we are going to continue on some of those triangles properties that we started in the last video. For this first part, we are going to look at a triangle and compare its side lengths with its angles. So if I tell you that its angles, this is the smallest angle in the triangle, and this is the medium angle in this triangle, and this is the largest angle in the triangle. Knowing the small, medium, and large angles can actually help us find the smallest, the medium, and the longest side. So if you look at this, if you go opposite from the smallest angle, that is going to give you the smallest side. If you go opposite of the medium angle, that is going to give you your medium side. And if you go opposite from your largest angle, that is going to give you the longest side. Which means, in return, if you have the small or the shortest, the medium, and longest side length, you can then find its opposite angle, and that gives you the smallest, medium, and largest angle, respectively. So let's write that out. We have the smallest angle is opposite the smallest side. Then the medium angle is opposite the medium side. And last, the largest angle is opposite of the longest side. Alright, so let's look at an example here. So if I have a triangle where I am given some measures, so this one's going to be 59 degrees, this one is going to be 34 degrees, sorry, my 9 and my 4 kind of look the same there we go, and then this one is going to be 87 degrees, then we can find which side is going to be the smallest, medium, and longest. So if we have our points A, B, and C there, our smallest angle is going to be 34. So if we go opposite of that, that is going to give us our shortest side. So remember, we have to name our sides with 2 points and our little segment sign on the top. Then if we want our medium angle, you just have to go to our medium or our middle measure, and that's going to be 59. Go opposite of that, and that's going to give us BC. And that only leaves us with one more side, which should be opposite of the largest angle, which it is, and that's going to get us AC. Some more properties of triangles that we need to know is something called the Isosceles triangle theorem. What the Isosceles triangle theorem says is if two sides of a triangle are congruent, then their opposite angles are congruent as well. So let's look at this real quick. So if we have a triangle and it's an isosceles triangle, so we know that two sides of them are the same. So if we're given that two sides are the same length, then what this theorem is telling us is that their opposite angles are going to be congruent as well. So we also have the converse of that. So the converse is just switching our P and Q. So if two sides of a triangle are congruent is our P, and their opposite angles are congruent is our Q, then switching those is going to be if two angles in a triangle are congruent, then their opposite sides are congruent. Alright, so you can remember the isosceles triangle theorem is we know isosceles triangles have two sides that are congruent. Alright, so that is given that you have two sides that are congruent. So the isosceles triangle theorem then says that their angles have to be congruent. So the converse of that is our opposite. So now we're given that the two angles are congruent, which means that their opposite sides have to be congruent. Alright, and the last property we're going to look at is the equilateral triangle theorem. And this is very similar to our isosceles triangle theorem. So our equilateral triangle theorem is just going to say if we are equilateral, which just means that all of our sides are the same, then we are also equiangular, which is just going to mean all of our angles are the same. So if we have a triangle and it's an equilateral triangle, we know then that our sides are all congruent. This is then saying that all the angles have to be congruent. So if we think about it, we know that all the angles in a triangle add up to 180. And we're saying that all three triangles have to be the same measure. All three angles have to be the same measure. So all we have to do is 180 divided by 3, and that gets us that all of the measures have to be 60 degrees. Alright, same idea as the isosceles triangle theorem. If we have that being equilateral is our P and equiangular is our Q, then the converse, we're going to switch those. So if we are equiangular, then we are equilateral. Alright, so this time we still have our triangle, but instead of being given that we have all the same sides, we have that we have all the same angles. And if we have all the same angles, then in return we have to have all of the same side length. Alright, thanks for watching.